Hey everyone, welcome to Cogito Code. In this video, we'll be learning about two new data structures, that is stack and queue. And this will be our agenda for this video. We'll start with some recap of our previous video in which we covered some basic data structures like array and queue. Uske baad we'll see what is stack, then what is queue. Uske baad hum kuch implementations dekhenge of stack and queue, like with the basic data structures, how they are implemented. Then we'll see some different type of queues. After that, we'll see in detail that how stack and queue can be implemented using arrays and linked list. And then at the end, we'll see what are the time complexity of stack and queue's different operations when we are using an array to implement them and when we are using a linked list to implement them. So let's start with the recap. Okay, so in last video, we talked about two data structures. First one was array and the second one was linked list. Okay, what was array? Array was nothing but a contiguous, the elements which are stored in contiguous memory. Okay, a contiguous block of memory. So this was array. And what was linked list? In linked list, we stored our elements not in a contiguous contiguous blocks, but in some random memory blocks. But it has one extra property, that was the address. So, and these were connected like this. So let's say this is our node A and let's say this is our node B. Then only A will have the address of node B and so on and so forth. Okay, you can watch the previous video if you have not seen it yet. But these two concepts we covered in detail in our previous video. So keeping that in mind about array and linked list, let's see what is a stack. Okay, so stack is a data structure which works in the concept of default or last in first out. Okay, a basic analogy for the stack will be, let's say you have a stack of books. So you started with your first book, then you stack a second book over it, then a third book, then a fourth book, then a fifth book, and you created a stack of books. Now, if you want to remove a book from this stack, which one will you pick, or which one will be the book which you will remove first? This one, the top one, or the one which came last, right? This was the book which came first, then at second this, and at third this, and this was the book which came at last. But when you come to removal of these books, then this particular book which will be removed first, the top one. So basically that is the concept of last in, first out, or LIFO. Okay, so there are some particular operations of this, like push. Push means you add something to the stack. Pop means you remove something from the stack. Or you can do also peek, or you can see that what is on top. So means you are not removing something, but you are just checking that what is there in the top. Okay, these are basically Python stacks or basic operations which you can do in a stack, and it is covered in most programming languages, but I am talking in terms of Python. Or also you can check that if a stack is empty or not. So these are some basic exemplary operations you can do on the stack. Once we understand the concept in more detail, that how it is implemented and other things, you can create more of the operations or whatever operations you want to create with hash type. Okay. Now, what was the next data structure was queue. Okay, and it works on FIFO concept. FIFO or first in, first out. Okay, so a basic analogy will be people which are there in a, let's say, movie ticket queue, right? So let's say this is a movie ticket counter, and here are some people. Let's say this is people 1, this is people 2, this is people 3, this is people 4, and so on. Okay, make some faces here. Okay, this is P1, this is P2, this is P3, this is P4. Okay, now these people are in this order, that P1 comes first, then P2, then P3, and then P4. Now what will be order that these person will come out? So obviously whichever person came first, that P1 came first, this guy will get the ticket and come out, and after that the P2 guy, after that the P3 guy. So whichever has come first, that will be come out first. So that is the basic concept of first in first out, or FIFO, or a queue. Some basic operations, those are Enqueue, means you add an element in the bag. So when our new guy P5 will come, where will it go? It will come here, right? So P5 will come here. So at the back you are adding something, that is your Enqueue operation. Then there is Dequeue, that is you remove something from the front. So as the definition suggests, first in first out, so whatever person came first, or the whatever element came first, that will come out first. Also you can see, do a peek here or front here, so you can see that, okay, which is the person which is at the top, or which is the element which come out next. Okay, and again the age empty operation, the basic operation, you can check it. Okay, so these were some basic intro. Now these both queue and stack can be implemented using array. So there can be a array based stack, or there can be a linked list based stack. Okay, same way you can implement queue using an array or a linked list. We'll see in detail that how these work. So, but before that, let's consider some types of queue. So one is like, let me write it, some types of queue. So these are some different variants of queue. One can be a simple queue. So the queue we discussed. Okay, and we'll see in detail that how these will be implemented using array and linked list. But just for example, let's say we are using an array to have this queue setup. So what we do, whenever we want to do this enqueue operation, we'll append something at the rear, at the back side, and whenever we want to dequeue something, we'll pull something from the front side, from this side. Okay, this is basic concept of an simple queue using an array. Now what is the problem with this, that as you keep doing this enqueue operations, sorry, dequeue operations, these positions will, these array positions, which was here, the one person was here, one person was here, one person was here. Now you pull these persons out. So what will happen? These places will get empty, right? Because just like pupil, elements don't step ahead on their own. Okay. So these uh, places get empty, and the next person which is here will come here. And when you are doing Enqueue or adding new elements, they will be added in the back. But this space is going wasted, which was in the front. So to tackle this, we use another type of queue, that is a circular queue. So what will happen? So let's say this you were keep doing Enqueue at the rear side, and when the list will be full, then your queue is like, so that it will show overflow, right? There's no more space, but there's empty space in the front at this side. So what does circular queue do? They will be connected like this. So whenever a list is full or a array is full, it will check again in the front that if uh, the space is there. So it will keep some pointers. So let's say these were your elements A, B, C, D, okay, E, and you put this, you will have a pointer at A that okay, this is my front, and a pointer at E that this is my back. And whenever you add something, let's say you added F here, then again it will shift this to this pointer. And when you pull something, so let's say I put A and B, so now my front is this. What will happen that let's say I added some more G here and the list got full, and now I want to add more elements. So this end pointer will come here at G, and let's say I want to more elements H, but there is no more space in the back. So what will happen? I'll check here that okay, there is a space because I have removed A and B, and I put H here, and let's say one more I here, and this end pointer will come and point at this, that okay, this is my end. So no matter where your elements are lying in that array, but with the use of these pointers that okay, this is my start, from this point I'll do Dequeue, and this is my end, from this point I'll do Enqueue. You can save the space which were wasted here. So this is the basic idea of a circular queue. Then there's priority queue. Okay, what does it do? It is basically a queue, but some elements can be in priority. Yeah, Ashwin, do you have any doubt?
Yeah, I just wanted to ask that these types of queues that we're discussing, simple, circular, priority,
Yeah.
is this based on the array or linked list, or is it applicable to both? Because some of the concepts that you mentioned that, okay, in circular we are pointing back to C. So
Yeah.
is that pointing only for array or is it applicable for linked list also?
Yeah, so
And
you can
yeah,
implement a queue using array and linked lists both. Now, once you have implemented it, you can again see that what kind of queue you want to build. So both like simple, circular, priority queue, all of them you can program using array or linked list. There can be a preferable way that if you, in certain cases, if you use array, that will be more preferable. In certain way, if you use linked list, that will be more preferable. But you can implement a
mm.
queue or an stack using array and linked list both, and after that you can build any of these.
So when we talked about simple queue,
Yeah.
you said that if we pop an element from the beginning, right? Like let's
Hmm.
say the first person goes out,
Yeah.
the other person won't automatically come. So why
Yeah.
don't we programmatically do it like we did in the deletion of the first element from array?
Yeah, but that will be again big of an operation, right? You don't want that. Every time you are removing one element and you are
Mm-hmm.
shifting all of them ahead, that will be like big of an operation. So
Okay.
you don't want that. That something which can be done in big of one. Why you need to do this? every time, right?
Okay, so basically we are doing the same thing as deletion of an element, but we're trying to figure out how to do it in
Better way,
a better way. So we have introduced types of queues for that.
right?
Okay, thank you.
So then there is priority queue. So it is basically a queue that again work in first in first out basis, that whichever has come first. And but there will be some certain elements or certain ways in which some VIP elements, okay, some VIP elements will get the priority. Okay, so this is not the exact way how we implement this, but I won't touch this topic in detail because it is a much more in detail topic, in depth topic, and it I don't think so will come handy in our gate preparation. But just to for you to know that there is something called priority queue in which some elements get VIP treatment and they get priority in the particular queue. Okay, then there comes double-ended queue or a doubly queue. What happens in such queues? So basically in most of the queue you do this Enqueue from the back and Dequeue from the front. Okay, so whenever some guy is coming or some new element is coming, you will add it from the back side of the queue, and whenever you want to remove something from the queue, you will do it from the front. What does this double-ended queue do? It makes the operation of deletion, or that is Enqueue and Dequeue, from the both ends. So you can add from this end and also remove from this end, that is back end, and you can also add and delete elements from the front. So that is double-ended queue. Okay, we'll see the time complexity of each of these operations which we have seen here. We won't discuss these queue in detail, circular, priority queue, and doubly-ended queue. These are just for you to know that there are certain kind of queue which are there. And once you know the implementation, the inner implementation of queue, you can create these or program these by on your own. Okay. So let's come into that how these are implemented. So let's start with a stack using an array data structure. Okay. So let's say we have a simple array or Python list. Now what you want to do? You want to do operation like push and pop or peek. These three operations we discussed. So what will happen? Whenever you want to push something in your Python list on an array, you can simply append, right? Append or add something in the back. That will be uh, your push operation. Now, if the list is empty, obviously it will be added here. And when there's one element, you will add one more element that will be added here, and so on and so forth. Okay. Now, when you want to remove something, from which side you want to remove it? From front or from the back? So obviously it is a stack which works in again last in first out concept. So whichever element, that is this element, whichever element came last, you want to remove this. So whatever the last element of your list is, right? You will simply return your last element. That is your, let's say if I use some Python terminologies and this is your stack, then you return a stack of -1. That is the last element. Okay. So remove the last element and return it. And if you want to just peek it that what is the last element, then you won't remove it, right? You have returned it, but also you need to remove this in pop operation, but it should not be there anymore. Okay, so you can just remove it, and there's Python operations and different operations in multiple languages by which you can just remove this to return stack and remove the last element, like return the last element and remove the last element. In peak, you will just return the last element, that okay, this is the last element, return a stack of -1, that is your last element, but you won't remove it because you obviously didn't pop, you didn't say that okay, come out of the stack, come out of the list. That was for pop operation, not the peak operation. Okay, and we'll see time complexity of all these. But let's say if we want to do the same thing using a linked list. Okay, so again, what will happen in case of linked list? You will have a head, and then you will have the other nodes, which will be pointing to other nodes. Okay, and again we need to do these operations, that is push, pop, and peek. Okay, again all the advantages of linked list will come again here, that you can do dynamic sizing. You want your stack can have dynamic size. Okay, so one way will be of push operation, that you simply add a new node whenever you are here at the head. So you added one element, let's say a, it come here. Now whenever you want to add a next element, you say okay, I'll add it next, like at this place. And whenever comes a new element, let's say c, you say that you add here. But with this approach, there's two problems. One, when you are adding it, you are doing an operations. So let's say you have already 10 elements in your list, and you are going to add an 11th element, then you have to hop through these 10 elements, right? So that is one issue. Again, one issue will be the pop element, that either you can have a tail pointer. Some people do this, that not only just head pointer, they also do have a tail pointer, that what is the last element. So in that case, obviously you can just remove the last element, but for removing the last element as well, you have to traverse through the second last element. Okay, so again the tail pointer will not help here. So again, for push operation and pop operation, you need to do this. What can be a better way? So a better way will be that whenever a new element came, you make it head. How does it help? So let's say your first element came, that is your a. Now when your second element came, you simply make it head, and making head is just a big of an operation, right? You added a new node at the beginning, and whenever third node came, you again make it head, and that will be your new head, and again it is a big of one operation. So now a push is not anymore big of n, it is big of one. What about pop? How does it help in pop? So if you remember, stack works in last in first out concept. So simply basically this head which came last, you have to remove it, obviously. So again, pop, you simply give this head and remove this head and make this new head. So you remove this C from here, and now B is your new head. And which operation? What was the time complexity of this? Simple, right? Big of one. You just removed one element. You didn't traverse through the AMP, right? Like we were doing earlier. So this is a better way to implement this stack via linked list. So again, whenever you are doing a push operation, what you do, you add new element as head, right? And pop operation, you remove head, right? Remove head and make the next element the head, obviously, and return it. Return it means to return the value, not the whole node, obviously. And then peek, you won't remove, you just see what is the value of the node. So obviously, if you remember from the linked list, there is a two part of a node. Here comes the value and here comes the address. So you have nothing to do with the address, that is just for the traversal. Your work is with the value, so you return the simply value. You won't remove the head or node, but you simply remove the return the particular value. Okay. So these two were implementation of array stack using array and implementation of stack using linked list. Now we can do same with queue. Okay. So let's say we're doing queue using array. Fine. So again, we have to do some operations, that is enqueue, dequeue. Okay, and we can also do pop or something if you want to, or not pop, sorry, peek or something. That we just want to see what is the next element which will come out of the queue. So what we will do, let's say we have this array. What is the queue's basic concept? That is first in, first out. Okay, so let's say any new element came. So let's say first A came, then B came, then C came. What you do, you will add it to the end of the list, because we are implementing a simple queue here. So first A will come from, then B will come, then C will come, and so on and so forth, D and E and so on. What if you want to do DQ? So for Enqueue, you just need to add the element at the end of the list, or do just append operation in terms of Python. Now, if you want to do DQ, what you will do, you will simply remove the first element, because whichever element came first, it has to be removed. So you remove the first element and return it. Okay. Whatever the first element is, you will remove it and return it. What about peek? So you'll simply see that, okay, what is the first element, whatever the first element is, and you'll just return it. You won't remove it, but you'll just return it to C. Okay. Now the operation, or internally how different languages do these things, the AQ operation that remove the first element and return it, and how it works internally. These things are not, we will not need to study it, because these will not come handy in our, like, in gate preparation from the gate perspective. This concept which we are learning, this should be more than, and this will be more than enough. And you can learn a bit from the Python language, because the concept or the concepts of this on stack and queue will come from the lens of Python language. So this is enough. This concept is enough. What will be the next thing? That implementing queue using a linked list. Okay. And again, what is the concept? First in, first out. Okay. So again, we have a linked list like this. And again, we need to do some operations like Enqueue, Dequeue, okay. And in some cases, let's say Now, how we will enqueue? It's simple, right? We need to just add something at the back. Let's say A come first, then B come first, then C come first, then B come first. So A, then we let B, then we let C, then we let D. Now you see the problem with it? The same problem which we have with stack, that we need to traverse, right? But the trick which we did with stack, that it can handy here as well. So let's say we try to do this enqueue operation just like that we did in stack. So whenever a new element came, we'll make it head. Okay. So let's say A come here, B come here, C come here, and D come here, right? So this will make it easy to enqueue, right? It will be, we need not to hop on the elements. But how will it affect the dequeue? What is dequeue? We need to remove the element which came first, which is where? Which is here at the last. So this operation will become, now for this operation we need to go till last, right? So for this operation, for dequeue operation, we need to do n operations. Or what if we did this earlier, like the normal, then enqueue will take big of n. So A, B, C, D. Now for enqueue, we need to do an operation, but our dequeue is sorted, right? We can just remove the head. So can you see the trade-off? If you use one strategy to implement queue using linked list, our enqueue will become big of 1, but our dequeue will become big of n. If we use another strategy, then our dequeue will become big of 1, but our enqueue will become big of dequeue will become big of 1, and our enqueue will become big of n. So what is the solution here? You can do some tricks and add a tail pointer. So you have a head and you have a tail pointer as well. Okay. Now when you have these two pointers, and if, because you am also saying that how you can implement in multiple ways using the named list or other. So if any questions such arrives that you don't have a tail pointer, you only have a head, and you need to implement queue using a linked list, then what will be the time complexity of enqueue and dequeue? You can think it through, right? The approach we are seeing, you can simply see that how many operations will enqueue take, will dequeue take, and what will happen if we have given a tail, what will happen if we have given a head. You cannot think it through. So this is the optimized way, that we also create a tail pointer, that which is our last node. So what will happen in enqueue, whenever we have a enqueue operation, let's say after A, B, C, D, E, after A, B, C, D, a new element E came. So we simply do this tail. We have this last node already. We don't need to hop from our head because we have our last node. So we can simply add this to here and update our tail pointer. So now this is not tail anymore. This is our tail. And whenever we want to dequeue, we can simply remove the head. So if we want to remove our first element, we need to dequeue something. So this will be B, C, D, E will be our new queue, and head is not this anymore. Head is this. Okay. And for peak, again, we can just simply see the head, right? We'll just return the value of that. Okay. Now, how do we do this? How do we remove the head? That is something in more depth, and we won't get into it because it is not related to our, again, from the GATE DSAI perspective. If you want to get in a detailed answer that how we will remove the head or how we will traverse, and so all these things, or the programs, how we do these things programmatically in Python languages or other languages, they are different, and many tutorials in available in YouTube. And if you want to create us to create some such tutorials, then you can comment down and we'll try to help you. Okay. Yeah. So this was it. Let's try to have a summary of each of this. That let's say we have a stack using array. We have a stack using linked list. We have a queue using array, and we have a queue using linked list. Okay. So one thing we can think of, that which of these are flexible in size. So we can think of size. Okay. So whenever, as you have seen the array lecture, if the Python list is obviously flexible, so that is a different case. But if we are using basic arrays, then this is mostly fixed, or you can call it dynamic if you are using list in Python, because the array itself is dynamic. For stack, which is used linked list, again it is obviously dynamic, because you can shrink or enlarge the linked list with your wish. Now for queue, again, if you are using a static or fixed array, then that will be fixed. And if you're using a dynamic array, just like in Python list, then it will be dynamic. And for queue, it will be again dynamic. Okay. What about space overhead? So again, arrays doesn't take any extra space, so both of them will be none. And here in linked list, again, because linked list have extra pointers, so these two will have extra pointers. Okay. Also, we can worry about overflow, that what if our list, what if our stack or queue got overflow, that allocated memory got fulfilled. So again, a stack, it is possible if you are using a fixed array. So overflow is possible if we are using a fixed array. For linked list, obviously there will be no overflow. Why? Because we are using a dynamic linked list. It has no particular size constraint. Again for queue, because we are using an array, it will be again possible if we are using a fixed array. And again here will be, it will be no. Okay. Then we can have other like access speed. So for stack, whenever we are using arrays, so you know that in arrays we have random access, so it can happen pretty fast. For linked list, we'll see the time complexity and that how it is happening. Okay, so I guess let's jump into it, and let's see the time complexities of different operations which we have discussed. That is push or enqueue in case of queue. So let me write that first. So again, we will have a stack which will be using an array. We will have a stack which will be using a linked list. We will have a queue which will be using an array, and we will have a queue which will be using a linked list. Right? And we'll have operations like push in case of stack and enqueue in case of queue. Okay. So again, we have discussed it that if we are using a stack as an array, if we want to do push, what we'll do, we'll just simply remove the, we'll just add a new element at the last of our array. So that is just big of fun. Okay. And for stack as well, we have seen the trick that we can simply, if we are using linked list, we can simply add a new head, right? We have seen that trick that we, whatever new element will come, we'll make it head. So again, this operation will become big of n. For Q, we are using arrays. Again, Enqueue is just, we need to add this to the end, that is big of 1. And if we are using Q, using linked list, then again we have seen that trick that we'll have 2 pointers, one for head, one for tail. And whenever we want to add something, we'll add it to after the tail. So that is again become just big of 1 operation. If some constraint is given that there is no tail pointer, then we'll see that which way we'll implement it and if it is big of n or big of 1, right? So if we have the tail pointer, then we'll, again, this is big of big of 1. Sorry. The next operation will be pop or dequeue in the front of in perspective of the queue. So again, if you are using an array with the stack, you just need to remove the last element, right? Remove and return the last element. With the array, that is just big of 1 operation. And if we stack using a linked list, then again we have seen that trick that because we just need to remove the head, because we, whichever new element is coming, we need to remove it, and it is based on last in first out basis. So again, removing the head is big of 1 operation. We are using a queue. So for pop, we need to remove the first element, right? So removing the first element, if we are using a dynamic array or something, then you need to shift. Let's say again, you can say that removing the first element is just big of 1 operation, but consider, if we consider that we need to shift the particular array, we'll need to shift all these particular elements to its left, then it will become a big of an operation if you are using a array, right? So for that, I'll write big of n here, and I add 2 stars because we are thinking of this inner operation that the list is doing, because it has to shift on this particular operation. What will happen if we were using circular linked list? What if we were using a circular queue? So we have talked about circular queues that from last we will be going here. So in that case, we didn't need to shift anything, right? We'll wait till the last element, like our queue to fill, and when the queue is filled, we'll again come at the front. Okay. So in that case, we'll say that okay, that can be big of 1. But I won't write it here. You understood it. And for queue which is implemented by linked list, you can see that we will simply remove the head pointer, head node, and we'll return it. So that will become big of 1. Then for peak or front, that we just want to see. So again, in this case, we can remove, if we can dequeue in 1, then that is big of 1 operation. Again, for stack, the first element we'll see that head and we'll return its value. We won't remove it obviously, but we'll just, what about here? Here we'll see the first value. We won't remove it. If we won't remove it, we don't need to do all these operations of shifting. So that will be big of 1. But we just check the first element, we didn't remove it, and we'll return it. And again for Q, using linked list, that is big of 1 because we'll just see which is the head, we'll return its value. Okay. So these were the time complexity of these particular videos. Sorry, these particular operations, not videos. And we can talk about space complexity as well. So if you are using n elements for each of the stack and queue, either you are using array or you are using linked list, the space complexity will be big of n for all of these, because you're storing n number of elements, right? So space complexity will be big often for all of these. Okay. So this was the basic tutorial for what is stack, what is queue, and how do we implement it using array and linked list, and what will be the particular time complexity, how the operations work under the hood, and how you can implement it in different ways. That okay, let me try this and let me try both, and you can do all sort of tricks to reduce the time complexity and the number of operations. Okay, so just a quick recap what we were trying to do. So we have seen that in recap, obviously we have talked about the array and linked list. What is stack? So stack is something which works in last in first out concept, and queue which work in first in first out concept. We see that we can implement both of these, stack and queue, using array and linked list. Then we see some type of queues, that is circular queue, we can have doubly ended queue, we have priority queue, and so on. Then we see detailed implementation, how we can implement a queue and stack using array and linked list. We can see some tricks, what we can use to reduce the time complexity. And then we have seen all the time complexities of all the operation, that is basic push, pop, and peek, and enqueue, dequeue, and or rear. Okay, so this was it for this video. We have a Discord channel again. You can join that Discord channel, and the link or the QR code that Discord channel should be visible in the screen now. If you have any doubts regarding this video, or you have doubts regarding any other topics in particular, some concepts or PDSA, ML, AI, you can join this Discord channel and ask about these. We'll be very happy to answer. And you can communicate with your peers how they are preparing and all. And you can also have a chance to come to these recording sessions and join, ask your doubts right here from us. Okay, this was it from my side. Thank you.